starting the recording now. So information for the sake of this recording on YouTube. I'm trying a format where I give private classes to a small group of people, and I'm anyway putting that later on YouTube for everybody to see. And so this test lesson is free for the participants. We'll just see how it goes. And, now we can start. This is the first problem, train maintenance from Codeforces yesterday. You can grab a link. Give it a read, and then we'll start talking at least about the brute force. The summary is that if on day 5 we open or activate the train with those parameters, let's say x is equal to 3, y is equal to 3, then it means it works in the cycle of size 6, and the first 3 days it is active, the next 3 days it is not active, it is in maintenance. So in this case, days 5, 6, 7 it is active, then 8, 9, 10 not active, meaning in maintenance, and so on. Active, first x then y, and so on. But also at some point we can later might say completely cancel this train. And days are from 1 to m, and there are events happening that we add a train or we cancel one.
And can it be added back?
Yes.
And if it added back, it restarts from active day 1?
It starts from the current day.
Okay.
So if on day 5 we have an event of activating a train with those stats, then it's exactly what I wrote down.
Okay. So we must keep track at what day each train is, for sure, somehow.
Yeah, if you just keep a set of pairs or something like that, then you will get this time complexity, or this one. I guess also we can say m times m, but n times m is fine. Here I would say in every day, go through all allowed types of trains and check if active. Meaning there was an event that triggered activating this train at all, and it's right now not in maintenance. All right, and then I'm waiting for ideas then. Any ideas? What do we use? Hopefully some wrong ones, so we could discuss about what doesn't work.
Yeah, so I had one idea here.
Yep.
Like just after reading the problem, I thought that uh, like, I still don't understand why it's not very trivial because I think that you can do events, right? Like for each uh, for each train, if it's whenever we add it, so you put an event of like if you add it on day t, you put an event of t plus x, which would say that uh, you'll switch its type like from active to maintenance or maintenance back.
Okay, but
And then
do you need to iterate over all the multiples? So you need to say, in this case,
no,
above.
you just do the next. Like so, you have one flag for which state you are currently on. So you know that you need to do plus x or plus y, right?
Okay, but
Like
then possibly on every day you will like have thousands of trains that you need to switch again. If there are a lot of trains and they have very short cycles, then you lost.
yeah, yeah. Okay, so basically we can have like all n trains every day. We have to switch them.
By the way, what you said
Yeah.
is
So sweep
equivalent.
line doesn't work.
Yeah, so sweep line is a reasonable idea because we deal with intervals of, for example, active status. But what you said is anyway equivalent to saying that on day 5 when we start this train, we iterate through all the intervals where it will be active in the future. 5, 7, 11, 13. What you described is the same thing, just you said that you will eventually do that. At each of those positions you will trigger the position 3 days later. But if for day 5 you'll iterate over days 8, 11, 14 and so on to mark in each of them in some way, that's too slow.
So what I was thinking of was, I don't know if it is correct or not. The For a given train, whatever like we have a cycle of x plus y. So in the range from t plus x to let's say t plus x plus y, we can use some data structure to mark actually existence of maintenance of this train, and then let's say at position t plus x plus y plus 1, we will again initialize it if it is not removed from our.
I think it's exactly the same thing. You both described the
Okay.
same thing where you want to like mark on day 5 something happens, then you mark day 8 as something happening, but then later if you get to I don't know 8 or 10, it will trigger the next one. It's still the same issue.
So I'm trying to think to iterate through all the trains instead than by day, and if for every train I know the interval when it goes on and off, I know what is the total number of day where it had been not completely cancelled.
Okay.
And at that point, I mean, it should be a simple division to know how many days that train was. No, but we need to say per day. It doesn't work.
Yeah. That's a nice idea. If we need to say what's the total sum of the maintenance counts.
Yeah.
Also, because the problem is difficult, it's fine to assume that we solve a simplified version of the problem where we are given info what trains are, and there are no events. We just need to say how many are in maintenance each day. So I suggest that we solve this version where you're given info on n trains. Each is just per xy. For each of m days, say how many are active, are not active. Maintenance. No events right now.
Okay, you're saying that all trains start at t equal to 0.
Yes,
Something like that.
yes. And they do not disappear. I mean, they go to maintenance and back. So now we got rid of events, kind of, and this one seems to be more just about math. In particular, if we add condition that x is equal to 1, or maybe y is equal to 1 is better, one of those two, then it will be almost like asking about divisibility. So, because this cycle size is very important. If something repeats every 5 units, then that's very regular. If there is like x equal to 9, y equal to 1, then the maintenance is on days let's say 10, 20, 30, 40 and so on. I'm not sure about off by 1. Maybe we should start from day 0.
So I'm still not sure how we can calculate for all trains, but of n into m solution is possible here. Like on day x, you just go through all the trains and there'll be a simple formula to check whether x day is a maintenance day for that train or not.
Yeah, but for a day, it's very difficult to do something smart. To do something smart about all trains. I would, for sure, during a contest, I would try to focus on a train, and looking at a train, I would think about its contribution to whatever is happening. So just like we from the very start thought that a train creates some interval.
I mean, every day I will need to check for every train what's the day modulus, the length of the whole period.
That's correct, but as I said, this would be very difficult to speed up. I think it's much better to focus on, we look at a train and we see how it affects other things. So, do you see how to solve a problem if all trains are of this format? There was simplification 1 that can somebody unmark? Somebody highlighted like 3 lines with their cursor. Can you just click anywhere on the screen? I think it will make highlighting disappear. maybe not. Okay, simplification one was that no events, just n trains from the start. And simplification two is that all pairs, or every yi is equal to 1. Every train marks something like those as maintenance days.
So if maintenance day is 1 only, then we can simply check with the modulo x plus y what is the value of the day.
But we could use modulo before, right? Like, yeah, the way before to check if a train is in maintenance is to check something like that, I believe.
I mean, if y is always equal to 1, I can keep a map that tells me for a given length of the whole cycle of a train, how many trains there are with that length. And on a given day, no, again, I have to look through that. Doesn't work.
For a train, like 9-1, how do we mark maintenance days? Given this simplification. And now, for the first time, I can say you are missing something easy here, and you should see the answer to this. Assuming the two simplifications.
You just want to mark all multiples of 10. Right?
Yeah, but this might be slow, right? Like linear if this value is small. Or is it? Or is it slow? Can you think of an algorithm where you go through multiples of values?
I mean, when we look for prime numbers, for example.
And what is the time complexity of primes?
Okay, so you will accumulate all, like, so that we don't repeat one multiple.
Yeah. If for every cycle size we only once iterate through its multiples, that's n log n total. Because this is equal to n over 1 plus n over 2 plus and so on plus n over n. So I should say, I think m, because m is the number of days. Let's assume that n is equal to m for because I don't want to think which one is which. Or at least they are, close. Okay. So if there are no two trains with the same cycle size, it is fine to iterate through such multiples. And if, assuming that our both simplifications, then indeed we can do it, because we can count how many trains are of this same format, x equal to 9, y equal to 1. And just for each of those, we will mark it. So we do something like for every train plus count of cycle size, and then for every possible cycle size, for cycle size equal to 1 up to, I don't know, n, or whatever is needed here, we iterate through multiples now. Maintenance of mul plus equal count of c. And this is n log n. Is this clear?
Yeah. And then I think generalizing the y to be anything was also pretty straightforward.
Indeed, now I want you to get rid of simplification too. But first, can everybody confirm that you understand this thing?
Yes.
Then we get rid of simplification too. How? And let's avoid this step by just saying no two trains are identical. Because that's just boring to, combine them. Let's just assume no two trains are identical. Then it's just for every train we iterate over multiples of cycle size. My question remains, how do we get rid of simplification too?
I mean, one inefficient solution is that we loop for y times and we mark consecutive days. But
I guess, indeed. Like if y's tend to be small, we can achieve this. Like where y is like limit of what is the value of y. But there is something not complicated.
Yeah.
Some not complicated too.
So yeah. So basically, we can just do cumulative this thing, right? We want to add on a range, and so we just add on L and subtract on R plus 1.
Indeed.
Yeah.
When you want to mark an interval and you want to add plus 1 in the interval, you can do it with a segment tree in logarithmic time complexity, or you can do it with running sums. So when you want to everything in interval LR say plus equal 1, then what we actually do is at some r a of L plus plus, a of r plus 1 minus minus, and later if we go through it, we will push this plus 1 to the right and it will propagate to the full interval. So now, assuming that indeed trains come first, and then we can do everything without events, we can use this. But there was also the assumption that no two trains are identical. Well, actually, if we want to say that the time complexity is n log n, then we need to say no two trains have the same cycle size. So this is, I guess, simplification 3. Okay. So summary is that we got rid of simplification 2 by saying that we use prefix sums or something like that to mark an interval to do plus 1 in constant time. Later, at the end, we will just go through all the days to propagate the sums. So I'm removing this. And here, then the solution is for every train we iterate over multiples, and we know, oh, this interval I need to mark, this interval I need to mark, and so on. And if cycle size 1, 2, 3, and so on, each of them appears only once, the time complexity is n log. But what if it's not?
If it doesn't appear only once, like if multiple trains have the same cycle size, you will have like for a fixed cycle size, you will have like a distribution of, because the two trains can have different intervals. So you basically want to add that whole interval to, like,
yeah. The issue is stuff like this, like two trains like this one, like those two, they both have cycle size 7, so we cannot for each of them iterate over those multiples of 7 because our time complexity will become quadratic instead of n log. It's n log only because for every number for every one number only once we went through multiples. If there are a lot of trains with short cycle sizes, that's bad. But sadly, those two aren't identical. We need to separately go through their multiples because they produce different intervals.
Yeah. So what I was thinking is that like we can do something like if it's 5 2, so that's like 3 4 5 and 2, and then the other one is run this way, right?
Yep.
So then what we want to do is for every interval of length 7 we want to add like, this array instead of only adding ones.
Idea is
But
good, but it
I
doesn't
think
decrease the number of intervals. Because if you have k trains with the same cycle size, like size 7, then here we have time complexity to iterate over those multiples of 7 is this, but then you need to multiply it by k because you have k distinct suffixes, and for each of them you want to add something. So that doesn't help. I appreciate the idea, it is reasonable, and I would also investigate that. So I would also try to combine in some way trains of the same cycle size.
I just a quick note here, like I don't understand this complexity.
N over 7
So
stands
where,
for iterating over multiples of 7. This is the number of operations.
yeah, and then
K is the number
so
of...
what I'm trying to say is that k is basically you iterated over all of these, right?
K here is
And
equal to
like
2.
add,
That's the number of such trains.
yeah. So what I am trying to say is that we can combine this into this, and we just want to update this like this thing once
Okay,
on the whole
how? And let
length of.
me say, let's talk about this. Now k is equal to 3. Tell me how you can add this to an interval in constant time. Because what I
Yeah,
think
I
you
mean,
need to do is you need to add 3 to some short interval, 2 to some short interval, and 1 to some interval.
yeah. Like I was thinking that maybe this is possible to do quickly, but basically we can't do that, is what you're saying, right?
Yep.
Okay. Yeah.
Do you agree with the following statement? If cycle size is big, cycle size of a train is big, then we can deal with that. Like, it's not an issue. If cycle size is at least, say, 100,000, it will add a constant number of intervals.
Yeah. So wait, I think
Now, are you
maybe
able
some
to...
square root.
Yeah. Indeed, we should split the trains into two types. Those with big cycle size and those with small. And the goal will be to get square root time complexity. To achieve that, let's focus on the following. Can we deal with small cycle size, like equal to 7 in nice time complexity? So in some other way than iterating over multiples. Because the final solution will be if train cycle size is big, and big will likely mean greater than square root of n. Just go through multiples, and the time complexity is O of the number of multiples. That's O of n divided by cycle size. But if cycle size is big, then this is small. If train cycle size is small, then what?
Then like the thing that I did here, we can do this in n by 7 times 7 also, right?
How?
because like you just go first place you add 0, second place you add 0, and like just go through these 7 things. So for each small thing you'll take n time. Like for
Okay,
each
but
small cycle
this is
size,
then O of n. That seems slow.
so it'll be n square root n, right? Like for each small cycle size,
I see.
you'll have n by c times c, which
Okay,
is O of n.
so get this like summary array for all trains of cycle size 7. So you create something like
Yeah.
this, and then you put it at every position from 0 to 6, from 7 to 13, from 14 to 20, right?
Yeah.
Okay, I see. And indeed, I agree. So we gather all the trains that have the same cycle size. We create such an array to see what they will do to every cycle of size 7, and then we just add in a naive way without any prefix sums. Just we add it to all the positions in the array.
I mean, this is very slow, no?
We can handle one cycle size in linear time, O of n.
Okay, and at most we have square root of n.
Exactly.
Small sizes.
Yeah. Length.
But if with this, I don't see how we can generalize like different starting times for trains.
Understandable. We got here, assuming that big means square root of n, then this thing is limited by square root of n. Small is up to square root of n, then we have n raised to power 1.5, so n times square root of n, but all trains come first, and like no updates, no events happen. Now, I will tell you what I thought about during a contest, but it didn't help. Maybe it can be used. I thought about divide and conquer, which is a very well-known technique for dealing with updates. I will remove some unnecessary stuff here.
And like, can we just add blank lines at the bottom so we can scroll?
Yeah, but later in playback it's very inconvenient to use. Like the bottom of code bank seems to be buggy. Now, divide and conquer over just queries / updates. This is a well-known technique where say that you can solve a problem if all queries, all updates happen first, then all queries. So there is something going on, there is information about trains, and maybe also they change, and only then you need to answer stuff. So this means that, in other words, you first do some pre-processing, and then you answer something. And this often allows us to, for example, use I don't know, prefix sums instead of a segment tree. But then there are more complicated cases. By the way, still here, it's not enough to just say we use segment tree and then we can go. That's not enough. Okay, so how this divide and conquer works? If in a problem, in particular in this problem, we have always update, query, update, query, update, query. Query means you need to print something. After every update in this problem, you need to say the answer. Then the solution is to do divide and conquer all those things, updates and queries, and process updates here, and using that, answer queries in this right half. Easier problem like this would be the following. Let's say that every query is, I don't know, adding +1 to interval or subtracting 1, and sorry, every update is like that, adding something to interval, and every query is give me the value of this position. Then I can gather only the updates from the left, process them in some way, and maybe I can do that if I assume that this can be pre-processing. Maybe I will sort them, run prefix sums. Then I answer queries from the right. What I do this way, what I achieve is I count contribution of updates from the left to queries to the right. And then I go recursively in both halves, and in this half on the left, I split it in two, here. And again, I process updates from here, and I apply it to answer queries from the right part, so from there. Just, it's, instead of treating all of that in such a, yeah, there is more stuff about it, but we'll not discuss it here. For now, let's say we can do divide and conquer to avoid the interleaving of queries and updates. And this adds additional logarithm. Okay. And this is what I tried yesterday during the contest first. I thought that we will need to do that. Sad thing was that still I wasn't able to solve it. Because even if all the updates are first, our solution from above doesn't really work because line 23 isn't that regular. Like it isn't just like this. Not everything starts on the same day.
Yeah, there'll be offset. Like,
there will be offset. So can we deal with that?
I mean, and not only it doesn't start on the same day, but something could interrupt midway.
But that's, so getting rid of a train is actually the same as inserting it. We will only put -1 everywhere instead of +1. Our time complexity here, luckily for us, is not amortized. Previously, we could possibly have O of n per single train if we iterate through its multiples, but it's summed up to n log n. I would call it amortized time complexity, even though it's very slow per operation. The total thing is not that slow. It's not quadratic. Here, luckily for us, every single event triggers only O of squared operations. So if we remove a train, it's not a big deal to just do the same that you did while adding it. Just subtract 1 instead of adding +1.
Makes sense.
Okay. So this divide and conquer here, it's not needed. And related, by the way, thing is called DSU order. Not really. I think I will later try to find a link for you to give you something to read, some article on that. But let's push this down and forget about it for a moment. It's not useful. Okay, so how do we deal with trains that don't start from day 0? Going through multiples works the same way, just, well, it will not be just multiples of 10, it will be multiples of 10 shifted. So maybe 15, 25, 35, 45, not a big deal. But, so issue. We can't use prefix sums if all of this is online. So we go through the sequence in the input and something happens and it affects some days, then something happens. Like, it's not true that all the updates go before all the queries. And one day to deal with that is to actually add the divide and conquer that I described. Again, it will make prefix sums hard to use, but maybe. Still, what about line 27? Here, we had a solution where we compute this array in line 23, and then we use it for the full thing. So actually, this thing was in O of n. And so if we repeatedly have something happening with trains, and each of them is O of n, it's exact the same train, well, that's bad. I guess I shouldn't have said about amortized time complexity. It's not amortized good time complexity. It's O of n per operation. So we need to get rid of this following step. We had step A, find array of size 7. I mean this thing. Step B is add it to positions 0, 6, 7, 13, 14, 20, and so on. I want you to get rid of this second step. What about this? Let's just remove the second step. I claim that it's enough to just maintain this array of size 7. Just remember it and don't do anything more with it. How do we now answer queries?
Yeah. So when you have this array and you're at day, some X day, you can see what day the day modulo 7 is and add those many to your maintenance.
Yep. This array actually, there is no reason for us to update its contribution to all the days, because that's wasteful, because this array will change in a moment. Instead, let's just keep it, and then when we are on day D, we can look at this array of size 7 and we can look at some single value that we know should be added to this current day.
Yeah.
This array of days of size 7, it should describe for every value of day modulo 7 how much we add, how many maintenance days happen on this value modulo 7. So this summarizes all trains of cycle size 7. And the time complexity of this is in total of number of queries multiplied by square root, because there are that many arrays, that many cycle sizes from 1 to square root. So it's okay. What about memory complexity? Because n square root of n memory complexity is big and you might get memory limit exceeded. With big complexities, time is usually fine, the memory might be an issue. So is memory here n square root n?
Memory is 1 plus 2 plus till square root, so that would be O of n, right?
I agree. It's fine. This is all of n. We create an array of size 1, of size 2, and so on, up to size square root of n. Okay, then what exactly happens when we have an update about a train with some small cycle size, like 7, and we see that it, for example, it disappears. On some day it disappears. What will happen with this array?
So the days it was contributing to, we'll subtract 1.
Yeah,
But now the point is,
With
Won't it be too slow?
some offset, we will just subtract 1 from some short interval. I mean short, at most size 7. Maybe an array a moment ago looked like something like this. That, let's say, that's a possible array. And now we have information, subtract 1 from this interval. And we just do it naively.
Okay, it won't be slow because we are only doing this for small cycle sizes,
Yes.
which are only square root of 1.
It's always fine for a query or update to do something in complexity square root.
Yeah.
So now we fixed 31. Everything we do in square root of n per query or update, except for this last thing. Prefix sums cannot be used if we do stuff online, if we keep going and we modify various things. Prefix sums can only be used if first we say add +1 here, +1 there, +1 there, and then we go through all the days. How do we fix that?
So what is the current, like, what are we doing for big cycle sizes? I only
Go
understood
through
the
its
small one.
multiples. So if cycle size is, let's say, 1000, go through multiples of 1000, starting from this current day. Let's say current day is 700. Go through 700, 1700, 2700, and so on. And for each of them, there will be some interval of size y where you want to say +1 or -1 if you cancel this train.
What is the current day? That is the day of when the train arrives.
Yeah, it's the current day. We iterate through all the days, and on every day something happens, something new happens in this problem. So just we know the current day.
Okay, why is this not too slow? Okay, because we only have at most one train like update each day.
Yes, but we cannot use prefix sums. So right now we don't see how to do 30, line 30. If you keep going through some sequence and you have events add +1, subtract 1 from the interval, the tool that the data structure that can handle that is segment tree. If it's not true that all the updates come first and then we have queries. We used prefix sums only because we had updates first. So one possible solution is segment tree. And it adds logarithm to the time complexity. I will show you in a moment how to avoid a segment tree. But for now, let's say that this is the case. So we have, then the total complexity will be something like, this is of n divided by cycle. I still assume that n is equal to m. It will be square root of n plus square root of n times log. This square root of n times log comes from those big cycles. Okay, first of all, n square root of n times log will have a hard time passing the limits. Because time limit is not huge in this problem. Like it's what, 2 seconds? Yeah, 1 second. Limits are 200,000. So I would think that 200,000 times square root times log will not pass. And segment tree isn't something extremely fast. You move through memory, you jump through like so nodes, so it's not consecutive space in memory. Yeah, it's so-so. A very well-known speedup for this, if you have uneven summation here in square root decomposition, is don't make square root exactly equal to square root. What actually happens always is that you decide some magic constant k, where you treat small things as those below k and big are those above k. normally we choose k to be square root of n. But you can decide for k to be slightly different to make those two terms to be equal to, because that's optimal. And if you want those two to be equal, you can from this compute that k squared needs to be equal to something. So k is equal to square root of, and in brackets, n times log of n. I will just say n times log, but it's logarithm of n. And then the time complexity improves to just n times square root of n times log, where log is still below square root. It's a small improvement, but it will give you that, I don't know, 3 times better running time.
Nice trick.
And it's a very common trick. Square root, the square root solutions where you do something else for big and small values, almost always they will give you some time complexity of both those parts, even if they have the same time complexity but different constant factor. It might mean it's optimal to choose some slightly different boundary for small versus big. And during contests, especially those with full feedback, like at Coder, what you can do is also just submit with multiple possible values of k. So, especially if you're running out of time. Square root of 200,000 is for something, I don't know, this, but I would submit this, and I would also submit 300, 600, if that doesn't pass, maybe 200, 900, I don't know, just try a few values. Because we don't perfectly understand constant factor. If you want to avoid wrong submissions, you can create some max test, if that's easy in given problem. In this train problem, it's not easy, because it's hard to say what is a max test, what will trigger exactly the max amount of queries, of operations. So yeah, here, hard to say, but for sure the time complexity we can achieve is the thing I'm highlighting right now. Whenever only one of the two parts is logarithmic, you can get square root of n times logarithm, where logarithm is also below the square root brackets. Okay, and finally, okay, time for questions if you have about those, about this thing. Then I will tell you how to get rid of logarithm. So now, logarithm. You see this sentence, we can't use prefix sums if online? It's bullshit, we can. This whole issue, that's not true. Actually, we can use prefix sums. And place where you will often use it is dynamic programming. This technique I see all the time in DP. It's just, you see, as you go through DP, as you compute some DP values, you often need, I don't know, the sum of previous values, or you need to propagate it forward to some interval, and it will be the same thing. You can use prefix sums for that. And to see what it does, let's maybe go to the top of the code, and I will show you what I'm talking about. Let's say that for every day we have some values li, b, ri, and I want to add +1 to this interval. Normally I would do this, +1 minus minus, and later I would here propagate everything. But instead of propagating later, I want to say that as I go, I propagate. So if I is not 0, pref of I plus equal pref of I minus 1. Just as I go through the sequence, also at some position, it might trigger adding something to future interval. If it's always just to the future interval, it works. So in the train problem, we have multiple intervals here. Actually, we iterate through some multiples, but still, if those are future intervals, everything is okay. But then, if Ri is smaller than I, then ignore. So just continue, because that was day in the past. I don't care about you. Because on every day, and my goal is just to here, well, print prefix of I. I guess I should do it here. Because this is the answer. And even without that, this code works if on every day you would be given information that there will be train in maintenance in some future interval of days. Like, sure, we add +1 somewhere, and when we get there, it will keep getting propagated to the right. Eventually, it will be cancelled by this -1. But this interval, if it's on the left, then that's not really possible in the train problem. So let's do it a little differently. I assume that Ri is at least here.
Even Li would also be.
And Li is more tricky. Here's what we need for Li. We maximize it.
Yeah.
I think this will be better. Maximize it with I, which means if you're on day 10 and you get information that from 7 to 13 you need to add 1, well, the 7 through 9 was already computed. I don't care about it. I will actually add 1 to this interval. And now it's okay. Because now possibly you add +1 here as well, and also you say that this will be cancelled sometime in the future, and we now can print this current thing. So the pref array, it serves both for the array of answers at the end and also for the running prefix sums. This is commonly used in DP. Example such problem is the following. Frog jumps n stones numbered 1 through n. Frog goes from stone 1 to n. Always can jump by at most k. Count paths, count ways. To get modulo billion 7. This is a DP problem. If k is very small, then we can solve it easily. For example, like this. I don't know, dp of I is equal to dp of I minus 1 plus dp of I minus 2. Something like this will work if k is equal to 2. If we can jump only by 1 or by 2. Well, there are out of bounds errors here, but we can deal with that. And to speed this up, we can use prefix sums. So one possibility is that this will be like get sum from I minus k to I minus 1, and this thing as a black box, it does something, so it will use prefix sums. But similarly, we can propagate forward. So I can say maybe dp of I plus 1 plus equal dp of I plus k plus 1 minus equal dp of I. I propagate value dp of I to the next k values. And assuming that I also do this, then done. I've solved the problem with running sums or prefix sums. If you have any questions, now's the time. I'm looking for some divide and conquer tutorial that would talk about those queries. find it. Anyway, what we did here is just the full solution in n square root of n, and it will easily pass. Not easily. I got in C++ 300 milliseconds out of 1 second. And here's two things that you need to watch out for. First thing is, if possible, avoid modulo operations, which means if in any bottleneck, if you see how to do something without modulo operation, do that, because it will, modulo operation is slow. Second thing is, I had one mistake when coding. When you have event of train disappearing, it's not the current day that counts, it's the day where it was first activated. So if on day 5 they say that some train starts, then later on day 20 they say that train actually ends, you need to look at what you did on day 5 and you need to repeat exactly the same that you did for day 5, just subtracting one. Gupta, can you mute yourself when not speaking, because there is some noise? Thanks. Okay.
Yeah.
Everything clear?
Yeah.
That was problem train maintenance. The
divide and conquer one was not clear.
I see, but I will try to later find some article to make it clear.
I think I've read. I have read one divide and conquer on queries article. I think it was by Adamant on dynamic connectivity problem.
All right.
I think they use a similar idea.
Makes sense. Yeah.
I think I have the link as well.
If you have a link, then sure, provide one. Right.
Should I put it in the code bank?
Yeah, you can do it in Codebank. Dynamic connectivity. Alright, so we have adding edges, removing edges. I think it will be indeed this divide and conquer I meant. Cool, thanks. I think we can wrap this up right now. I don't want to start a new topic. So closing the recording.